Hi everyone. In this video we're going to go over parallel circuits, and we're going to look at a physics regents problem from a few years ago that deals with equivalent resistance. So the problem says a 20 ohm resistor R1 and a resistor of unknown resistance R2 are connected in parallel to a 30 volt source as shown in the circuit diagram below. An ammeter in the circuit reads 2.0 amperes. Part A says determine the equivalent resistance of the circuit. I started things off by circling my numbers and units. I boxed these two keywords. I think parallel is a keyword because it might help us pick a formula, because there are different formulas for series and parallel circuits. And then I boxed ammeter because that might help you remember that the 2 amperes is measuring current. And I underlined equivalent resistance because that's my unknown. When they say equivalent resistance, my first thought is this formula for a parallel circuit: 1 over Req equals 1 over R1 plus 1 over R2 plus 1 over R3. And I normally would be able to use this for a parallel circuit, but only if they give me both resistances. Or if there's all three of the resistance values. But since they don't, they only give me the 20 ohms and they don't give me R2, there's no way I'll be able to use this. So I'm going to start by listing out my unknowns. I know that the potential difference is 30 volts. I know that the current is 2 amps. I know R1 is equal to 20 ohms. And it's important that I label it R1 because I don't want to get this confused with R2 or the total or equivalent resistance. The equivalent resistance is what I'm looking for. Now, I sometimes like to think of equivalent resistance as the total resistance for the whole circuit, because it helps me keep track of what I can and can't use for a certain problem. So if I'm looking for the equivalent resistance, I should really only be including information that applies to the circuit as a whole. So I'm actually going to cross out R1. It's true that R1 equals 20 ohms, but I really shouldn't be using that for this particular problem. I should only be using information that applies to the whole circuit. So I have V, I, and I'm looking for R, which means I can use R equals V over I as my formula. When I plug in my numbers, 30 over 2, I get R equals 15 ohms. So that's the equivalent resistance. Part B says calculate the resistance of resistor R2. Now, I'm going to underline resistance and R2 because I'm solving for resistance, meaning I'm solving for capital R. And there are 3 different resistance values that we're dealing with, so it's important that I know which one I'm solving for. I'm solving for this one. So that's my question mark. In this case, I can use the formula for equivalent resistance in a parallel circuit, because now I have the equivalent resistance. It's 15 ohms. I just solved for it. I know R1 because they gave that to me, and I'm looking for R2. So I can use this formula. I left off the last part, which would say plus 1 over R3, because there's not 3 resistors. If there's just 2 resistors, I only need these 2 terms. So it's very important that you don't plug in the 15 and 20 as R1 and R2. The 15 is R equivalent, so I'm putting that here. The 20 is R1, and R2 is my unknown. At this point, I'm going to plug this into my calculator. You don't necessarily have to do that right away, but that's how I'm going to show it here. I'm plugging each of these individual fractions into my calculator. So 1 over 15 becomes 0.067, 1 over 20 becomes 0.05, and then 1 over R2 is just going to stay the same because I don't know what R2 is yet. I want to get 1 over R2 by itself, so I'm going to subtract 0.05 from both sides. That's going to leave me with 0.0167 equals 1 over R2. Here's where it gets a little bit tricky with the rounding. Technically, the physics regents isn't supposed to take off points for rounding, but if you round so much in the middle of your problem that your answer is too far off, you may not get the credit. So that's why it's important that I'm really doing 0.0167. I wouldn't want to just cut this off at 0.01 or round it to 0.02. That would probably be too far off. And then your other option, of course, is to just keep the fractions for now. 1 over 15 equals 1 over 20 plus 1 over R2. Instead of changing that to a decimal and then subtracting 0.05, you could always just subtract 1 over 20 from both sides and keep them as fractions up until the end. So either way would work, but if you're doing decimals, make sure you do have a few decimal places. Remember that this is not my final answer because I was looking for R2, not 1 over R2. So I have to do my last step, which is doing 1 divided by this number that I got. When I plug that into my calculator, I got 60. If you got 58 point something or 59 point something, we're going to be rounding that to 60. And that's because if you did carry out all the decimal points, like if you left the 0.016 repeating in your calculator and did 1 divided by that, it would go exactly to 60. So 60 is our answer, 60 ohms, and that is for R2. Part C says how much power is dissipated by R1. So I underlined power because that's my unknown, and I'm underlining R1 because this should remind me that I can only include information that's specific to R1. So for example, 2 amps, I'm not allowed to include that in this problem because that's the amps for the whole circuit. It's not the amps just for R1. So I do know R is 20 ohms because that was given to me. I also am allowed to use V equals 30 volts because in a parallel circuit, the volts are the same for every circuit element. So yes, this is 30 volts for the battery, but it's also going to be 30 volts for R1 because it's a parallel circuit. I'm looking for power, so I can use the formula P equals V squared over R. When I plug in my numbers, I get 45 watts.